In previous questions, what we did was we looked at the second derivative and we go, okay, it says dy dx equals 1, so we always went with phi equals dy dx. And that was really handy until now. What we then did was we changed the second derivative is the derivative of the first derivative, and we know that the first derivative was v, so it's the v dx. So what we do here is we change this thing here to the v dx. So we say the v dx equals y. Anybody see a problem? Anybody at all see a problem with that equation I'm trying to work on right now? Three variables. The y variable isn't part of the integral of v and the integral of x. It's like it's completely wrong choice. Okay. So what we're going to do is we haven't done anything wrong. What we're going to do next is we're going to get the v dx and we're going to go, okay, put the v here, put the dx here, and then choose the letter that you need it to be. We're going to choose the y, top and bottom. That's using the chain rule. And what did we say dy dx was? V. So it's now phi the v the y. And trust me, that you're going to have to do that trick about 10, 12 times before it starts sticking with you, okay? So we're going to change this here to v the v the y equals y. What is the goal of this question when you look at the derivatives? The goal of this question, y is on top, x is on the bottom. You're not happy until y is on its own on one side and there's some sort of x variable equation on the other side. That makes sense? So you start going through this. You go, okay, I'll just rub out everything else I did for a minute and back in a second with that. So what we're going to do here, guys, is we're going to cross multiply this. So we're going to get phi dv equals y to y. Not the hardest one we've ever looked at. Integrate both sides. Now, when this is v, when phi equals 1, y equals 1. When phi equals phi, because this is a dv function and this is a y function. Integrate both sides. What are we going to get on the left hand side? Phi squared over 2. And then on the right hand side, y squared over 2 from y and 1. Okay, what happens next, guys? Sorry? Okay, so phi squared over 2 minus 1 squared over 2. The 1 squared over 2, basically a half. No worries there. And what about the second part? Y squared over 2 minus 1 squared over 2. 1 squared over 2 also being a half. Now, half cancels with a half. And then you're going to be left with phi squared over 2 equals y squared over 2. The 2's will cancel as well. Now, phi squared equals y squared. Okay, square root both sides. Phi equals y or minus y. Now, you're going to see in your solutions it goes, it can't be minus. And that doesn't make sense. Why can it not be minus? When you get a situation like this, you check your limits. So what I mean by your limits is this. We have two options, don't we? Two options are phi equals y or phi equals minus y. Check it out here. It specifies that phi equals 1 when y equals 1. 1 equals 1 is perfect. However, if this is minus y, see the way 1 equals 1? It would only work for the minus limit if it says phi equals 1 and y equals minus 1. That means that this equation here is inconsistent with the limits, therefore we choose phi equals y. Is that alright? Now you're at the stage where you've gone through your first integration. Now you're going to go through your second integration. Phi equals y. Okay, what is phi again? Phi is dy dx. Dy dx equals y. And I'll do it up here. 1 over y dy equals 1 dx. Integrate both sides. What limits are we going to use? X and y on top and on the bottom. 1 and 0. We're going to ln it. It's 1 over y, which is ln y. From y to 1. The other one is going to be x. From x to 0. Integrate. ln y minus ln 1 equals x minus 0. What is ln 1? ln y equals x. Anybody know how to finish that? Exactly. Leave the y where it is. The x becomes the power. Y equals e to the x. Now, once again, guys, we're looking here. We'll not be satisfied with the answer until it's y equals something, some equation with x only. I know this because it's a dy over dx. Okay. Next thing, I look at the one of the limits. The differentiable one is phi equals dy dx, and that equals 1. So phi equals 1. We then set up the second derivative. So d2y dx squared is dv dx. Is that okay? Now, dv dx is, therefore, it's dv dx equals minus 2 over y to the power 5. We have a problem here. The problem is that it's a dv dx integral, but yet I have my equation in terms of y. So in order to fix that, I use the chain rule. I get my dv dx here. I always separate out the top one and I slide the other one beside it into two fractions. I then choose the letter that I have here. It's a y, so I say dy here and dy here. Then I realize, wait a minute, I labeled dy dx as v, so it always turns into phi dv dy. I don't have that learnt off. I actually understand it. And what you find is if you just try and learn it off by heart, if the letters get jumbled up, if I give you a dx dy equation, it's all upside down and people make massive mistakes. Try and understand that it's just a chain rule and you do the same thing to match it up every time. Once I've done that, I get phi dv dy equals minus 2 over y to the power 5. I'm then going to integrate it. So I'm going to keep the phi dv on its own, and the phi dv on its own, and I'm going to get I'm going to leave the minus 2 on the outside, and I'm going to get y to the minus 5 dy. I'm going to set up the integral signs here and here. Phi equals 1 when y equals 1, and this is a phi and that's a y. Integrate. So let's integrate. So when we integrate, what we're going to get is phi squared over 2 from phi to 1. We're going to get minus 2 times the integral of y to the minus 5 is a difficult one. It's going to turn into y to the minus 4. And then when I differentiate it, it's going to be a minus 4. So it has to be all divided by minus 4. So when you integrate it, divide it by the new power. I'm going to, before, yes? Okay, here, dy dx. I said phi is dy dx, so phi equals 1. And y equals 1 when x equals a third. So they both simultaneously take on the value of 1 when x is a third, so they're 1 at the same time as each other. Fit in. Guys, what we have here next is we look at both sides, and I'm going to multiply the minus 2 by the minus 4. Make it easy on myself. Minus 2 by the minus 4 gets me a 2 on the bottom. Now I have my y and my 1 here. Cool with that? Phi squared over 2 minus 1 squared over 2. 1 squared being just a half. Okay, next thing after that, guys, y to the minus 4 all over 2. And then minus 1 to the minus 4 all over 2. 1 to the minus 4, still just 1. A half and a half. A 2 and a 2. Phi squared equals oh yeah, didn't make the mistake. Yeah, that's grand. So phi squared equals 1 over y to the power of 4. Everybody cool with that? Next thing, square root. Phi equals 1 over, what happens when you square root y to the power of 4? Y squared. It's basically y to the power of 4 to the power of a half. And using the multiplication rule of indices, it's y to the power of 2. It can indeed. Now, which one is it? That is the question. Okay, can you back up that statement of why it is the plus? Sorry? Has to be... it's about the limits, and they both have to equal each other, so we'll find out when we go back to the top. I can't see them at the moment, so I'll just bring it up here. So, I'm looking at them, and what I know is that phi equals 1 when y equals 1. So 1 equals 1 over 1 squared. That one works. However, 1 equals minus 1 over 1 squared. 1 does not equal minus 1. Therefore, the second one is inconsistent and doesn't work. Yes, Gary? We're at the stage now where... oh, there it went anyway. Phi equals 1 over y squared. That's where we're at. We still haven't got a formula with y in terms of x, so we're still searching. So, that's phi, looks like a y. Now, phi is the y dx, and that's 1 over y squared. Cross multiply, y squared dy equals 1 dx. Now, integrate, x here, y here. Now, what are the lower limits? 1 and a third. Okay. Integrate both sides. What do we get? Y cubed over 3, good man. And then after that, x, and that's x to the third. Now, y cubed over 3 minus 1 over 3, it's 1 cubed, but 1 cubed is 1, equals x minus a third. Okay. Oh yeah, I didn't finish this one off because I thought it was easy. Now, what happens at the very end then, guys? y3 over 3 equals x. Finish it off for me. Y cubed equals 3x. Then it's just going to be the cube root, isn't it? You can write it as 3x to the power of a third, or you can write it as the cube root of 3x. Just want to check that out. I didn't actually take that one to the finish line. There we are. So number 3 is done. How many? Okay. Now, solve this equation. I will not be happy until x has a equation with some form of t on the other side. Alright, start off and I go, oh, this one here, that's always going to be v. Phi equals dx dt. Therefore, the second derivative of it is dv dt. For those of you who aren't really settling into this, it means the derivative of the first derivative, and I'm just after specifying that the first derivative is v. Hence the it's a dt on the bottom. Hence the dv dt. Is that right? dt squared as well. So dv dt equals. I'm going to multiply this out. Not keeping it like that. Okay. So 18x plus 2x cubed. Everybody happy with that? Wrong choice, because the x's are blocking it from happening. Is that right? So because the x's are blocking this from happening, we're going to reevaluate our decision on the second derivative. Second derivative is dv dt. I know if I separate it out, and then I pick the letter I have, everything will be hunky-dory. Okay? So what is dx dt? V. So it comes phi dv dx. So phi dv dx ends up to be 18x plus 2x cubed. Cross multiply phi dv equals 18x plus 2x cubed dx. Integrate both sides. And how when we integrate? X on top, phi on the bottom. 9 on the bottom for v, and on the bottom for x. Gives you sort of two sets, doesn't it? Is it x0 or x3? x0. When. Keyword when. Okay, so at the same time. So x equals 0. Integrate. Phi squared over 2 from phi to 9 equals, what's that going to be? 9x squared. And then the other one is going to be a half x to the power of 4. Remember, 4 times a half is 2. Take 1 away from the power, 3. X and 0. Now, what happens next, guys? Phi squared over 2 minus... What's that, 9 squared over 2? Pretty whopper. 9 squared over 2 being 81. And the other one, 9x squared plus a half x to the 4. This one. This is fun. Multiply top and bottom by 2. We don't like when the denominators aren't the same. And to be honest, I don't really like denominators full stop. So there we go, get rid of them. Now, get phi on its own. 18x2 plus x4 plus 81. Anybody in the class see the pattern? Okay. In maths, we usually put the biggest power to the front, the second power to the middle, and the number at the back. We can also see that it follows a pattern of 18 and 81. So if I was to say let y equal x squared, this equation would technically look like this, which in turn is a perfect square. But I'm just after specifying that my placeholder y is in fact x squared. So what we're going to get is phi squared equals x squared plus 9 to the power of 2. What does that mean for v? V is x squared plus 9. Now, or the negative version. But look, I'm not going to do that formal check again. It's the positive version. Okay? So, we're after doing all this work to get all the way down to phi equals x squared plus 9. What is the next stage then? After that? Phi equals x squared plus 9. You go back to the very start. Now everything you did here no longer affects anything. Okay? So, phi equals x squared plus 9. Was it x squared plus 9? Okay. Phi is the x dt ends up to be x squared plus 9. Cross multiply. Now I'm going to turn that 9 into 3 squared. Anybody know why I'm doing that? It's in anticipation of a tan inverse logarithm. Oh, sorry, tan inverse logarithm. Tan inverse integration. Because eventually I'm going to have to integrate this. And as I stated to you guys, the only way to integrate an x squared with something else on the bottom beside it is tan inverse. Okay, when you integrate it, when you have 1 over x squared plus a squared, when you integrate this, it turns into 1 over a tan inverse x over a. In our specific question, the a value is 3. So with an a value of 3, we're going to work this. I still haven't put in my limits. X here, t here on the bottom. 3 and 0. 1 dt. Integrate. 1 over 3 tan inverse x over 3 equals, after that, t from t0, and I obviously forgot my limits over here as well. What's it? X and 3. Let's go with this. 1/3 tan inverse x over 3 minus 1/3 tan inverse 3 over 3. What is 3 over 3? 1. What is tan inverse 1? So it's going to be 1/3 of pi over 4. Everybody cool with that? So it's going to be 1/3 tan inverse x over 3 minus pi over 12 equals t minus 0, which is just t. Cross multiply. Oh, so not cross multiply. Bring the pi over 2 to the other side. You are looking to isolate the x. That is the goal of the question. X in terms of t. So, what we're going to do here is we're going to bring the pi over 12 over the other side first. And then we're going to get a third tan inverse x over 3. Multiply both sides by 3. And I'm going to get 3t. And what happens when I multiply this by 3? Pi over 4. Get rid of that third. Tan inverse x over 3. How do I get rid of the tan inverse? Bring it to the other side and turn it into tan. X over 3 turns into tan 3t plus pi over 4. Bring up the 3. Answer is x equals 3 tan bracket 3t plus pi over 4.